We are looking at iron plus your copper cupric sulfate actually. So we have this to be iron. This is your copper sulfate, also known as cupric sulfate. So this naming convention, I'm yet to put the basics, how to name them, why is the name so. There's a pattern there too. We'll understand that in time. I mean, I'll put it, actually, might have put it by the time you guys are watching. So do go back to the basics, then you'll understand why the names are so. Iron, sulfate, and you might be wondering what is this 2 I've written over there. That 2 will make sense as and when you guys are getting exposed to the concept. In the basics, that is, naming convention. Then this is nothing but your ferrous sulfate. Then yes, Cu is your copper. So basically, cupric sulfate and iron gives us ferrous sulfate and copper. So is it balanced? That's the next question. So let's look at it. So we have Fe, CuSO4, and the other end we have FeSO4 and Cu. So in the reactivity series, we know that iron comes above Cu, and so the reaction is happening. Again, reactivity series is in the previous video. Now let's list all the things that is involved in the reaction. We have iron, we have sulfur, copper, and oxygen. Agree? So let's map it out. This is 1. So in Fe, just Fe, one atom of Fe is there. CuSO4, CuSO4. In FeSO4, we have FeSO4, and in Cu we have, now it looks to be balanced, 4 4, everything else is 1 1 1. So it's balanced. So let me make it clear. Fe is solid, CuSO4 is aqueous. That is, it is mixed, or it's in water. That's the most simplest manner we can put it across. Then Fe2SO4, again it's in aqueous, plus Cu, solid. Right, guys? Now, reaction indicators. So how do you get to know? First is our color change in solution. So we'll start with this. We'll get to see a lot of color change. We need to remember all of this. So first we have blue color. Okay, guys. So we'll start with blue color of your, copper sulfate solution. So basically because of copper ions, which will gradually fade away. So this will fade out as the iron sulfate, which is pale green, is formed. Okay, so that's the very first thing. Then formation of the solid. So a reddish brown solid, that is metallic copper, will deposit on the surface of the iron. So since we started off iron to be a solid material, so we'll get to see a reddish brown solid. Reddish brown. This is nothing but your metallic copper. That will deposit on the surface of the iron. So on surface of iron, that's what we started off with. We dipped iron metal. So we'll see all of this practically. And one more indicator is heat is generated, heat is released. So this indicates that CuSO4 is less stable than FeSO4. That's the whole formula, right? And so this is exothermic. So there is change in the appearance of indirectly the same thing. The shiny gray iron metal will be consumed as it reacts, and a reddish brown copper will be deposited in its place. Okay guys, so the same second point itself, but yeah, this is how we can see that this reaction is happening. So fundamentally, for now, all I can tell is your Fe is above Cu in reactivity series. How did we come up with reactivity series? That itself is quite complex. So we're not going into that, but that's the most fundamental thing that you can understand over here. And the next thing is why the heat is generated. By now you should be able to guess. CuSO4 along with iron, they are at higher energy level, while your FeSO4 and copper, they're at lower energy level. So there is a drop from higher to lower. And this difference in energy is nothing but, right, it will be released as heat. As simple as that. Again, I'm putting it in a very simple manner. We'll try to add in more information with the actual experiment so that you have a better grip. For now, I think this is good enough for you guys.